I want to show you something today, something you have seen 1,000 times, something so ordinary that you have never once stopped to wonder about it. Strike a match, go ahead. If you have one nearby, strike it. Watch the flame appear. Watch it dance on the tip of the wooden stick. Feel the heat on your fingers. See the light flickering in the dark. Now I want to ask you a simple question. What is happening? You will say the match is burning. You will say the fire is hot. You will say the flame is destroying the wood, turning it into ash and smoke. You will say this is obvious. You learned this when you were 5 years old. Fire burns things. And I am going to tell you that you are wrong. Fire does not burn. Fire has never burned anything. What you think you know about fire is completely, fundamentally, beautifully incorrect. Now wait, before you throw this aside and call me a madman, let me explain. Let me show you what fire actually is. Because when you truly understand it, when you see it for what it really is, you will never look at a candle flame the same way again. Let us start with what you think is happening. You strike the match. The friction creates heat. The heat ignites the chemicals on the match head. A flame appears. The flame spreads to the wood. The wood burns. Eventually the match is consumed, and you are left with a small black stick of charcoal and ash. This is the story we tell ourselves. Fire eats things. Fire destroys things. Fire is a hungry beast that devours whatever it touches. But this story is wrong. It is backwards. It misunderstands the fundamental nature of what is occurring. Fire is not a thing. Fire is not a substance. You cannot put fire in a bottle and carry it around. You cannot weigh fire on a scale. You cannot touch fire, not because it would burn you, but because there is nothing there to touch. Fire is an event. Fire is a process. Fire is something that happens, not something that exists. Let me say that again because it is important. Fire is not a noun. Fire is a verb. When you look at a flame, you are not looking at an object. You are looking at a chemical reaction made visible. You are watching billions of molecules rearranging themselves at tremendous speed, and the light you see is a side effect of that rearrangement. Think about a waterfall. Is a waterfall a thing? You can see it, you can hear it, you can point at it and say there is a waterfall. But the waterfall is not made of any particular water. The water is always changing, always flowing through. The waterfall is a pattern, a shape that the water makes as it falls. If you stop the waterfall would disappear. There would be nothing left to point at. Fire is exactly like that. Fire is a pattern that matter makes when it rearranges itself in a particular way. The flame you see is not a thing. It is a process happening so fast and so continuously that it looks like a thing. Now here is where it gets strange. Here is where everything you thought you knew falls apart. You say fire burns the wood. But what does burning mean? What is actually happening to the molecules in that match? Let me tell you exactly what is happening. And I warn you, it is not what you expect. The wood in a match is made mostly of cellulose. Cellulose is a long chain molecule, a polymer, built from carbon, hydrogen, and oxygen atoms, all linked together in a specific pattern. These atoms are held together by chemical bonds, and those bonds contain energy, stored energy, potential energy, energy that was put there by a tree using sunlight years or decades ago. When you strike the match, the friction creates heat. That heat starts to shake the molecules. It makes them vibrate faster and faster. And when they vibrate fast enough, something remarkable happens. The bonds begin to break. The The long cellulose chains start to fall apart. The carbon atoms separate from the hydrogen atoms. The hydrogen atoms separate from the oxygen atoms. The molecule that was wood begins to disintegrate into smaller pieces. But here is the crucial part. Here is what most people never understand. Those atoms do not just fly apart and disappear. They immediately find new partners. They form new bonds. The carbon atoms grab onto oxygen atoms from the air and become carbon dioxide. The hydrogen atoms grab onto oxygen atoms and become water vapor. New molecules are born from the death of the old ones, and when these new bonds form, something is released. Energy. The energy that was stored in the wood, the energy that the tree spent years collecting from the sun, that energy is set free. That energy is what you see as light. That energy is what you feel as heat. That energy is the flame. So when you look at a fire, you are not watching destruction. You are watching transformation. You are watching atoms changing partners in a dance that releases the stored sunlight of ancient summers. The wood is not being destroyed. The atoms of the wood are still there, every single one of them. They have just rearranged themselves into new configurations. Carbon dioxide and water vapor and ash, nothing is lost, nothing is created. Everything is transformed. Fire does not burn things. Fire is what transformation looks like when it happens fast enough to glow. Now I want to take you deeper. I want to show you something even more disturbing about fire, something that will make you question everything you see. Look at a candle flame. Really look at it. You see the yellow part, the bright flickering tongue of light. You see the blue part at the base near the wick. You see the dark space right above the wick where the flame seems hollow. What are you looking at? Most people think they are looking at burning gas. They think the flame is made of some kind of fiery substance, some glowing material that exists between the wick and the air. But that is not true, not even close. The yellow part of the flame, the part you think of as fire itself, is not gas. It is not plasma. It is not any kind of substance at all. It is dirt. Let me explain. When the wax melts and travels up the wick, it vaporizes. It turns into a gas. That gas rises up into the flame. And in the heat of the flame, something happens to it. The long hydrocarbon molecules of the wax begin to break apart. They crack into smaller pieces. But here is the thing. In the center of the flame, there is not enough oxygen. The oxygen cannot get in there fast enough. So the carbon atoms that break free from the wax molecules cannot find oxygen partners. They cannot form carbon dioxide. They are stuck. And what happens to carbon atoms when they get very hot but cannot react with anything? They glow. Those carbon atoms, those tiny particles of soot, are heated to over 1,000 degrees. And at that temperature, they radiate light. They glow yellow and orange and white. They are incandescent, just like the filament in an old light bulb. The yellow flame you see is not fire, it is glowing dust. It is trillions of tiny carbon particles heated to incandescence, radiating their stored heat as visible light before they finally find oxygen and become carbon dioxide. When you look at a candle flame, you are looking at glowing dirt. Now look at the blue part at the base of the flame. That is different. That is where the real chemistry is happening. That is where there is enough oxygen for complete combustion. The carbon atoms find their oxygen partners immediately. They form carbon dioxide without ever having time to glow. The blue light comes from something else entirely. It comes from excited molecules, from CH radicals and C2 molecules that emit blue light when they form and break apart. It is chemiluminescence, light created directly by chemical reactions, not by heat. So a candle flame is two different things happening in the same space. Blue chemistry at the base, glowing soot in the middle, and darkness right above the wick where the wax vapor has not yet begun to react. This is why I say fire does not burn, because fire is not one thing. Fire is a whole collection of processes, all happening together, all intertwined, all creating the illusion of a single dancing object. But it gets stranger still. Have you ever wondered why flames always point up? Have you ever thought about why fire rises? You probably think it is because heat rises, hot air goes up. That is what they taught you in school. And that is true, but it is not the whole truth. The real reason flames point up is gravity. When the air around a flame gets hot, it expands. It becomes less dense than the cool air around it. And because it is less dense, it floats. Just like a bubble of air floats up through water, the hot air around a flame floats up through the cold air. This creates a current. Cool air rushes in from the sides and bottom. Hot air rushes up from the top. The flame is stretched and pulled by this current. It is shaped by the flow of air around it. The teardrop shape of a candle flame is not the natural shape of fire. It is the shape that gravity and convection carve out of the chemical reaction. How do I know this? Because we have done the experiment. We have taken flames into space, into the weightlessness of orbit, where there is no gravity to create convection currents. And do you know what flames look like in space? They are spheres, perfect little balls of blue light, no teardrop, no flickering, no dancing, just a quiet, steady sphere of combustion. In space, there is no up, there is no convection. The hot gases do not rise because there is no rising. They simply expand outward in all directions equally, and without the constant flow of fresh oxygen that convection provides, the flames burn cooler and bluer and smaller. The candle flame, you know, the dancing teardrop of yellow light, is not what fire wants to be. It is what fire becomes when gravity grabs it and pulls it into shape. Fire is a collaboration between chemistry and physics, between molecular reactions and fluid dynamics, between the nature of atoms and the nature of space itself. Now, I want to tell you where the energy comes from, because this is the part that connects fire to everything else in the universe. This is the part that will make you see fire as something cosmic, something ancient, something miraculous. When you burn a piece of wood, you are releasing energy. That energy shows up as heat and light. But where was that energy before? Where did it come from? How did it get stored in the wood in the first place? The answer is the sun. Let me tell you the real story of fire, the story that begins 93 million miles away on the surface of a star. The sun is a nuclear furnace. In its core, hydrogen atoms are being crushed together with such tremendous force that they fuse into helium. And when they fuse, a tiny bit of mass disappears. That mass becomes energy, pure energy, energy described by the most famous equation in physics. That energy fights its way out of the sun's core. It bounces around for thousands of years, working its way through the dense solar interior. And finally, it escapes into space as light, photons, little packets of electromagnetic radiation streaming outward in all directions. Some of those photons, a tiny fraction of them, travel 93 million miles through the emptiness of space and hit the Earth. they hit the leaves of a tree. And now the magic happens. Inside the leaf, there are tiny structures called chloroplasts. Inside the chloroplasts, there is a green molecule called chlorophyll. When a photon from the sun hits a chlorophyll molecule, something extraordinary occurs. The photon disappears. Its energy is absorbed, and that energy is used to perform a chemical miracle. The leaf takes carbon dioxide from the air. It takes water from the ground, and using the energy from that captured sunlight, it tears these molecules apart and reassembles them into something new. It builds sugar, glucose, long chains of carbon and hydrogen and oxygen linked together in a very specific pattern. This is photosynthesis. This is how plants eat sunlight. But here is what I want you to understand. The energy from that photon does not disappear. It is not used up. It is stored. It is held in the chemical bonds of the sugar molecule like a coiled spring waiting to be released. The tree takes that sugar and transforms it into cellulose, into wood, into bark, into the hard structure of its trunk and branches. And locked inside that wood, invisible and patient, is the energy of ancient sunlight. Some of that wood falls to the forest floor. Some of it gets buried. Some of it becomes coal over millions of years. Some of it gets cut down and turned into firewood. Some of it becomes a match. And when you strike that match, when you create enough heat to break the chemical bonds, you release the energy that has been waiting there all along. The light you see is not new light. It is old light. It is sunlight that was captured by a leaf and stored in wood and is now being set free again. When you watch a fire, you are watching the sun. You are watching stored starlight being released back into the universe. Fire is a memory. Fire is the forest remembering the summer. Fire is ancient photons, finally completing a journey that began in the heart of a star. This is why I say fire does not burn, because burning implies destruction. Burning implies that something is being lost, but nothing is being lost. Energy is being transformed. Matter is being rearranged. The carbon that was in the wood is now in the air as carbon dioxide. The hydrogen that was in the wood is now in the air as water vapor. The sunlight that was in the wood is now in the room as heat and light. Nothing is created. Nothing is destroyed. Everything is transformed. Now I want to leave you with one final thought, one final image that I hope will stay with you. You are made of the same stuff as fire. The carbon in your bones, the hydrogen in your blood, the oxygen in your lungs. These atoms have been through fires before. They've been inside stars. They have been part of burning forests and volcanic eruptions and the slow combustion of ancient oceans of bacteria. And right now, as you listen to my voice, you are on fire. Not with flames, not with visible light, but with the slow, controlled combustion of metabolism. Your cells are burning sugar right now. They are combining glucose with oxygen and releasing energy. The same chemical reaction, the same transformation, the same ancient sunlight being set free. You eat food. That food contains stored sunlight captured by plants. Your body breaks down that food and releases the energy. You use that energy to think, to move, to live. You are a slow fire, a carefully controlled combustion, a flame that has been burning continuously since the moment you were born and will continue burning until the moment you die. The only difference between you and a candle flame is speed. The candle burns fast and bright and brief. You burn slow and steady and long, but the chemistry is the same. The transformation is the same. The ancient sunlight being released is the same. So the next time you see a fire, the next time you light a match or sit by a campfire or watch a candle flicker in the dark, I want you to remember this. You are not watching destruction. You are watching creation in reverse. You are watching the sun come out of hiding. You are watching atoms dance from one partner to another, releasing the energy that was stored when the world was young. Fire does not burn. Fire transforms. Fire liberates. Fire remembers. And so do you. Every breath you take is a tiny combustion. Every thought you think is powered by ancient starlight. Every beat of your heart is a small fire burning in the darkness of your chest. You are made of fire. You are sustained by fire. And when you finally stop burning, the atoms that were you will go on to burn in other forms, in other lives, in other fires yet to come. That is the truth about fire. That is the disturbing discovery. You are not watching fire from the outside. You are fire. You have always been fire. And now you know